All right, let's get started. So, welcome everyone to roll call number one. The original plan was to host this in Istanbul, but due to the circumstances, that didn't end up happening. But I think a lot of us managed to still get some fruitful discussions in, a bit more piecemeal while we're over there. So, today we want to start by discussing some of the new RIPs that are being proposed, and yeah, then get into some of the other topics. So would like to start with the SecP 256R1 precompile, which is being moved from being EIP 7212 to becoming RIP 7212. So basically, the EIP will be deleted and recreated as an RIP. And the idea then being that we can move it into final call. So asking for comments on what the status of that. Well, basically comments or objections to the RIP as it stands. So yeah, I'd like to hand over to the Clave team to discuss if there have been any changes or basically where all of this is from their perspective.
Hello. Thanks for including in the agenda. I hope everyone is fine. I'm sharing the EIP page in the chat. Currently, we are okay with the specifications as the co-authors, and we received some feedbacks. And recently, we have changed the address of the precompile implementation and changed it into the next available address, which is proposed in the one of the other precompiles, but not active yet. I have asked to the Matt, the light clients, and he suggested to use this address 0x0b, and there is no other change, and I think we are ready to go to the last call and discuss with the rollup teams about any possible changes, and we would love to implement any decided change to the RIP version, and we are also currently waiting for the RIP, specifications. So for example, how should we propose the existing EIP as an RIP? What should we do as numbering, as the file structure? Should we delete the EIP? There are a few discussions in the EIP editors section in the Discord. We are also following it and ready to do any change and discussions.
Thanks, Uros. Yes, Dano? Dano, if you're speaking, we can't hear you.
Oh, all good. I was just saying that we're excited about it. And yeah.
Cool.
Can you hear me?
Yeah.
Yes.
Okay, my mic was on the wrong system. So with the B1 address, what are the implications for the layer 1 teams? Will they be obligated to ship it at B? There was already L1 proposals for BLS 12, where B was one of the proposed numbers. What happens if L1 decides to do another precompile next that is not R1? Are they obligated to skip B and go to C? How will that impact compatibility? Would something in like the thousands be a more appropriate? I mean, I'm concerned about B1.
Ansgar suggested that to blocking that address for the future for this specific precompile.
Right. So yeah, I think basically we'll see this kind of happen more and more frequently in the future anyway. That we have precompiles that ship on layer 2s first, but still are a very reasonable candidate for layer 1. And so I think standard procedure should really be to basically just block the precompile address on layer 1, So even in the case that layer one never ships something, that these never ship something conflicting. But of course, we are not in a position to fully commit to this here. So this was basically the only remaining item on my list before moving this to this IIP to final would be to double check with the layer one teams and get them to commit on basically blocking this address once the IP turns into final.
Okay.
But I'm open to
Yes,
open to suggestions if, for example, you think there's a strong reason why you'd want to have IIPs precompiles be in a different range, even if they potentially could target mainnet at a later point, then we could discuss that.
So yeah, I think that should be discussed with the on the ACD call. But I think that actually brings up a second question: is precompile coordination registry, because there are going to be chains that have precompiles that matter just to them, rollups, and there are ones that we want to share. We also want to make sure there's no collision. So I think the second thing that should fall out of this is some sort of a precompile registry RIP.
Yeah, I personally, I think that's a great idea. I think like the very pragmatic first step on this would just be that we wanted to have IIPs basically have a section where they indicate which layer twos have implemented them once the IIP turns final. Of course, that's not as good as a central IIP as one place where you can see all of them. So I think that as a second step should also follow. Where we the only question there is do we list basically all of the IIPs that are just individual to specific rollups, or only the standardized ones?
Harry?
Hey, yeah, I think this is what I think I had posted a little bit about this in the chat after last time. I really like the idea, and I'm wondering what other people think about here. Actually trying to get sort of names like let's say 3 namespaces of precompiles. Like there's the current implicit namespace, which is basically the all zeros prefix, which is used by L1 development. But we could potentially just have sort of like a different prefix, like 0x1 00000, and then 1 2 3, and then 2, and basically have like the 2 other prefixes being one being a RIP fully owned prefix, where if Ethereum wants to, like, it'd be awesome if they also adopt the RIP and just also have it in that prefix. I don't think people really care about about precompiles being incrementing from 0. And the other being a rollup specific prefix where rollups could put precompiles and have a guarantee that like neither the EIP process or the RIP process would collide with theirs. And then we could just never worry about this again.
Yeah, I think the idea of having separate namespaces makes a lot of sense. There's much easier to maintain registries and that kind of thing. Ansgar?
Yeah, I would say just as a pragmatic kind of next step then, because I know that the R1 precompile authors really want this to get to final as soon as possible. So I would propose that we basically bring this up as a topic on the next RollCall call. I'm not quite sure. That could be because of the holidays. Then this might, I'm not quite sure when that is, but basically make a decision over there whether people prefer kind of just using the normal range and blocking them, or having a separate range for IPs, with the understanding that mainnet would then also ship in they say the R1 precompile if we ever were to ship that on R1 also at the IP address, basically. Just confirm with them, and then get back to the IP authors, update the IP, and at that point then, if there's not been any other update to the IP, move it to final.
Yeah, I mean, one of the really cool things about precompiles is that we have as much space as we need. It's not like opcodes where it's sort of contentious as to the availability, and you'd need extensions, etc., etc. So this just giving us a really large namespace seems very, very possible. Haichin, I hope I was saying that correctly.
Yes, yeah, that's correct. So actually, my question is like so for example, the R1 precompile case, that it's potentially like the layer 1 can also pick up this precompile in the future, and that means like putting the different namespace will be weird. Like if the layer 1 eventually pick up this precompile.
I think it's not that bad. It just like it means that when you're calling into it on the layer 1, it would also be at this other address. I think it's more just like delineating so that we don't have conflicts. As was already mentioned by someone earlier on, I don't think most people care what the address is of a contract they're calling into. So then it shouldn't matter all too much.
So one small thing I would float here, the R1 precompile is mostly useful for account abstraction wallet contracts, and those are created at create two addresses that can be the same across all chains. I don't think it's unsolvable, right? So you can still make a contract that multiplexes on chain ID to call into one address on Rollups and another on L1. But if you want a single contract to exist both on L1 and on Rollups, then it makes it somewhat simpler if it exists at a single address.
Yeah, we could definitely solve it with some kind of switch here, but that would be, I think, just if we can avoid that, that'd be great. Paul, you mentioned in your comment that it's not quite as simple as that. In the chat, do you mind elaborating?
Yeah, I mean, this is kind of the tax you pay for precompile every time you call something. Even if you don't use a precompile, you need to know if it addresses a precompile or not, because it affects many other aspects. So this information is kind of critical. And if you overcomplicate it, like how you like determine if an address is in precompile, then like everyone has to pay this additional cost. So yeah, if it's like if you use like whole addresses, like the prefix in the beginning, then you need some kind of map or I don't know, but so for now it's just a range from 1 to some number, and the number changes by the hard fork number more or less. It's not, I think, big deal, but something to consider that if you introduce gaps, that changes how it works currently. So there are some number of complications that involve. I think it's not like showstopper. I think it makes sense to have the same precompile on the same address. So some reservation is fine, but yeah, I'm not sure I want to use the whole address space for a precompile. So there's number of trade-offs. Like one example is that a precompile is always kind of warm access. So you need to know how much you will pay if you even check the like code size of some account. You need to know if it's a precompile or not, and that kind of breaks all of this abstraction.
Okay. Thanks for explaining some of those complexities. Jordi?
Yeah, well, one thing that I would like to put on the table is what would happen if the instead of defining a specific address, we define the address of the equivalent smart contract written in Solidity or in VM. I mean, you have let's say a canonical smart contract written, for example, this signature verification, whatever. I mean, you do it in Solidity, you have a smart contract which is very well defined. You have the definition in VM. It's very clear. It gives compatibility. So if you don't, if for any other rollup, if they don't want to implement something specific, they already have something. We know for sure that we don't have any consensus problems. And the only difference here is the gas price. I mean, maybe there is some chains that decide that certain smart contracts have a different gas price. But for me, this has the advantage that we don't need to deal with addresses, but has also the advantages that all the precompiles that are standardized, they come with a very clear I mean, a very clear definition. We have a consensus, very clear consensus, so that there is no doubt if you implement it in one way or the other.
I mean, I think an idea like that is very cool, but it does require all implementations to be like correct and audited and that kind of thing, which adds, I guess, a little extra complexity because now we both need a really solid compiled version as well as the pre-compile, as in like Solidity compiled or whatever your favorite language is. I think that's a little complicated. It also would certainly complicate the checks that Paul is talking about, because now these would be deployed all over the place. But I do think these are interesting directions to go in, and yeah,
And you avoid
this
you avoid you avoid consensus things. I mean, different interpretations of the precompile from different chains, different people. I mean, imagine that there are some edge case that in one chain is done in one way, in the other chain is done in the other way, and so I'm afraid on this, and having a canonical EVM. Standard EVM precompile that does that. I mean, this is the standard is the canonical. I think this is a good thing.
So then in the case of the EVM implementation differing from the precompile due to some kind of bug somewhere, what is the correct version? How do we address something like that?
I mean, the thing is that it's precompile. I mean, the idea is that and with this any chain, if you change the code, then you change the precompile address. So the precompile is it's defined by that address. If you change a single line of code, or because you fix, you correct, or whatever, you will have a different address. So there is no doubt what you are executing. So it's like it's smart. It's precompile, but it's not. It's like a compile smart contract. I mean, it's a smart contract that's just doing that. You can deploy that smart contract in any chain. You know that this smart contract is going to work, so you get compatibility out of the box to all the chains with a very clear way it's done. And then the only thing you do is just for acceleration, okay, because you have some specific implementations, then specific rollups can decide to just lower the price of some precompilers. But lowering the price is much easier to deal with. I mean, different interpretations, different versions, different chains, some chains that implement something, the other chains that don't implement something. Just trying to simplify.
Yeah, I think those are all valid points. I think there's still a lot of complexities we need to hash out there in terms of exactly how we do these progressive precompiles. So I think let's table the progressive precompile discussion for now, and we can try, like we can have this discussion in a different context later. But yeah, definitely interesting things to think about here. Andreas?
Yeah, just a question from a pure developer experience, right? And a Solidity compiler point of view, right? I mean, you have chains that implement it, others don't, right? And do they implement it exactly the same way? So I think that's actually a big problem. So the canonical way of doing it, I think, is absolutely required. Otherwise, you're going to screw with developer experience, security. It's like you're doing R1 signature on one. It's not exact. It doesn't verify on the other chain, even though it should. Right? There are, especially if you're doing like bridging and stuff like that. There's all kinds of things that really require saying no, it has to be done in a particular way and only that way. Otherwise, you're breaking things all over the place.
So to be clear, part of the purpose of this whole standards effort is like to have that one canonical way. So the idea behind having this R1 go into final call now is that this is the implementation that we'd like to ship. It should be the same across all chains, modulo some weird bug. But yes, if you're going to do it this way, or if you're going to do it differently, then have it at a different address, kind of thing. Ansgar?
Yeah, I also just wanted to briefly say on the topic of progressive precompiles, because I think that this is an idea that has come up before. I don't think it's quite in time to take this into account for, say, the R1 precompile here and which address it should use, but it's something worth following up. There was the idea, because we of course wanted to have the in-person event in Istanbul, which unfortunately we could not do. We had a few topics, and like the progressive precompiles was on the agenda, if I remember correctly. There was an idea that we could, starting maybe after the holidays in January, we basically have a few breakout calls, optional breakout calls, centered on, like, each call centered on one of these topics from the agenda, or additional topics if they come up by then. Maybe using the same time slot kind of on the off weeks where we don't have this call for people interested. So I think those would be a good forum then to have kind of more in-depth conversations around how to do these things. But I don't think it would be a good idea to kind of block deploying kind of a precompile that's ready to go now until we have figured out this topic.
Ahmad?
Yeah, just looking into that from the compiler perspective and developer perspective, it is of course a good thing to follow a canonical way, especially for L2s. But there is a reason why we there is a separation between what is to be implemented on L1 and what's to be implemented in L2. And one of the reasons is that not everything that is implemented in L1 makes sense to be implemented in L2. Like given, for example, for 844, blobgas v opcode, like for example, the 4788 a precompile, etc., etc. So for these, it does not really make sense. Like if we're like all like, I'm not like trying to stir up things here, but EVM equivalence, etc., does not make sense in these cases, right? And in this case, we need to look into, okay, probably here we need to know what we're compiling into. Is this smart contract being compiled into an L2? And if that's the case, certain opcodes needs to be known that they're not compatible with an L2, for example. These opcodes are made for L1. So like, I'm all for canonical way of doing things, but it's mostly like it should be known that this is for L2 and does not necessarily apply to L1 all the time.
Yeah, I think that's a very valid point. Yeah, basically the idea that we're going to have L2 native compilers, or maybe feature flags for certain RIPs, etc. I think makes a lot of sense in the compilers in terms of what this would look like, and I think that's something we're gonna have to figure out on this call, and yeah, for all the tooling moving forward. Paul?
I'm not sure I fully agree, but I really like this idea to have at least kind of reference EVM implementation. And I know some L2s already are doing this. They have precompiles implemented in Solidity or EVM, and they just deploy the code at the given address. So I don't think that like the address deploying on is so big deal. I mean, the benefits of that it's much greater in my opinion to have that. Because if you don't have a capacity to like implement it in the whatever the backend you have, you can just use EVM for this reason. It also works great as a reference spec. Otherwise, we need to reach out to some other sources to understand what to implement exactly. And in the specific topic of this R1, we actually want to have implementation EVM Max. I don't think this will be like for deployment, but at least for the spec might be good use for it. And we want to like check how well it works in this context.
Thanks for that, Dror.
Regarding the namespaces, I think it's less of a question whether all L2s will implement features of L1 or vice versa, but on the other way around, do we want to prevent ever merging features from L2s into L1s or the other way around? And I think there is a consensus that we don't want explicitly to block merging. We don't want conflicts. So it makes sense to have one namespace and one place, whether it's RIP or the core dev or someone that will do the minimal work of managing this namespace of numbers. It's not that someone is going to be neither L1 nor L2s to have thousands of numbers. There's going to be a small, maybe tens number of numbers. And so you know that this namespace will always be precompiles and just have this unique numbers authority like Yana on the IPF, on the internet, to manage these numbers, to make sure that they never overlap. I think that's what one of the charters of having this RIP. So it will make eventually when cross execution, cross compatibility between networks will be added, it's going to be simpler than separate namespaces.
Yeah, I think that's a very valid point. I think Ansgar's getting to that in the chat as well. Yeah, having a single registry, probably in the EIP's repo of this would make a lot of sense then.
Yeah, I think, but since Dror mentioned the Yana, I think like how it's done on the internet, I think having a namespace and no collision for possible future merging is important. But maybe what Harry suggested of having also a range which is private and is never merged, this is probably okay. The equivalent for this is the private address range for IPs. There are certain IPs that you are allowed to allocate in any way you like, and you know that it doesn't need to be compatible with other networks, whereas the rest of the IP range is allocated. So I think the equivalent here would probably be to have like a certain prefix under which things can be different on rollups, and this is rollup specific stuff. And anything outside this particular range is a non-conflict zone.
I mean, if that's a path that people would like to go down, to be able to have separate things that people are deploying on their individual L2 EVM implementations, I think that's totally fine. This would create quite a lot of branching and divergence in terms of implementations then, in terms of what gets deployed. But if there's demand for it, then sure, I don't think there's any reason not to do that. Harry?
Hey, yeah, I just wanted to add, in terms of, and I kind of wish we were doing all of this like 3 years ago. I just, I could speak to both Arbitrum and Optimism already have kind of custom chain specific precompiles. I'm not sure about other rollups, but I wouldn't be surprised. Arbitrum, unfortunately, and this is definitely a regret, just used like I think we're in the like 200 range or something. We sort of, rather than namespacing, Optimism, I'm pretty sure namespaced all of their precompiles behind some specific prefix. Oh yeah, 420. Well done on their part. So yeah, this is a bit kind of like there's already this issue.
Yeah, but this is it. But the past precompiles are all known at this point. So if we choose to standardize it this way, we could have a document that covers all the current ones that are used by any rollup, and just not add any more of them without using the new namespaces.
Yeah, I think that's going to be one thing that we're going to have to just manage going forward on everyone's front, is that there already is a lot of deployed code and a lot of people have had to make practical decisions in order to actually deploy their L2s, and so this means that we're going to need to think about these things and handle them as they come up. Anyways, moving on, the next topic I'd like to touch on is RIP 7560. And that is the native account abstraction one. I believe we have someone who wants to come on and talk about that.
Yeah, I think I will present about it. So RIP 7560, it is heavily based on the previous ERT 4327 that we made for account abstraction. So I'll give a brief overview if somebody is not very familiar. What we try to solve is the ERC 4627 for account abstraction is to allow smart contracts to feel like an actual account native for the users. And we try to achieve it without introducing a consensus change or like changes to the VM. So the way it was achieved back then was done with deploying the entry point contract. And this entry point contract is a specific, like, it's a very important contract that was audited many times. And this contract coordinates basically all the process that is happening with the account abstraction. And the block building is separated, and blocks of transactions that are abstracted, that we call user operations, is delegated to also separate parties, which are bundlers, to put all of them together into a single large Ethereum transaction of a legacy type. Right? Can you hear me? It has...
Yes, we can hear you fine.
Yeah. Okay, great. So the RIP 7560 takes it one step forward by introducing basically the same principles of account abstraction ERC and of user operation as a new transaction type. So in general, we propose to create a new transaction type, and we want to reserve number 4 for this transaction type. And this transaction defines multiple additional fields for to define the sender, to abstract away a signature, and we have some additional features like multidimensional nonce support and a gas abstraction and execution abstraction built into this transaction type. And validity ranges. So the transaction is a little bit bigger. And another step that we are taking is we want to introduce multiple top-level execution frames for this transaction. So this transaction will not just include a single call that's done from an EOA to the target, but this transaction type can include up to 5, I think, or 6 top-level like execution frame like calls. Like first phase of this calls is to establish if the transaction is generally valid and eligible to be included in a block, and the rest is the actual execution of this transaction body. So we do define like a number of interfaces, and these are Solidity interfaces. These are very similar to how they look like in the ERC, but with some changes that were probably necessary. And I think, yeah, another thing that like we realized while we're working on it is it is a pretty complex task for the block builder and like to the one who operates the mempool and is filling a block to put this transaction in a block sequentially, because the transaction can change the state, which means that they can affect each other's validity. So a single transaction can flip a flag, and then the next transaction is not valid. So as far as I know, like this is not addressed in the previous account abstraction EAP. 2938, if I'm not mistaken, that we need to isolate the code that is running in validation from being modified also by other transactions in the same block. So what we propose in the RIP is to cut these transactions like in two parts, basically, and apply the validation part together before execution. So if you have 3 transactions, then you're running transaction 1 validation, transaction 2 validation, transaction 3 validation, and then you're running transaction 1 execution, transaction 2, and so on. So I think I should post the link to the EAP itself, RIP itself. Yeah, I'll post it here. And in addition to that, we did define a very extensive list of storage rules, which means that we want to limit the validation code. And we are doing it in order to protect block builders. So if block builders want to break these rules, they are free to do so. It's just that they might be exposed to some kind of denial of service attack because they allow the validation code to invalidate a block, basically. And these rules belong to an ERC that I think is relevant, so I will share it as well here. And what else should I mention? Yeah, I think that the multidimensional nonce, this is something that we already do in the ERC, but we want to make it a more native part of the blockchain. So we propose to introduce a 256 byte long nonce that will be split into 2 parts. And a sequential 64-bit value and 192 bits of arbitrary data. So multiple, like to enable smart contracts to have multiple channels, like smart accounts, to have multiple channels of execution in parallel. If you have like separate groups of people interacting with the accounts at the same time. So it seems like we will achieve that with a pre-deployed contract that manages this as part of actual Ethereum state. So this is another part. Okay. I think this is it. Like another thing that is a very important part of account abstraction for us is gas abstraction. So we allow a so-called paymaster contract to accept paying a fee for a given transaction. And in that case, the entire payment of gas is abstracted from this contract and not from the sender. And because we are adding gas abstraction and validity ranges, like we are considering extending this to EOA contracts as well, because eventually if we introduce a way for EOAs to inject code into their addresses, that would make a lot of sense for them to do it with a type 4 transaction that is subsidized by a paymaster and has a validity range and benefits from other additions from this transaction type. Job, Dror, did I miss anything you wanted to say about the RIP? And if there are any questions.
First, no, not about the RIP, but I wanted to add something about the motivation behind it. So this RIP is actually this is actually what triggered the creation of this group of the RIP process of RollCall, because we saw that I mean when we worked on ERC 4337, we wanted to standardize account abstraction so that wallet developers can build once and deploy everywhere. And this worked great, but then some layer 2s wanted to get better efficiency and other benefits of having native account abstraction. So we've seen Rollups starting to enshrine a version of 4337, which they adapted for their needs in different ways. And then we started seeing wallets that only support one chain. Like, for example, Argent stopped supporting EVM chains and switched to supporting only one chain that has native account abstraction. So this motivated the creation of the RIP process and also of this particular RIP, which is meant to standardize native account abstraction for those for chains that wish to have the benefits of native account abstraction. So it's just the background for how it all started.
Thanks, Alexander and Yoav. Does anyone have any questions relating to this RIP? Yes, Stas?
Yeah, hi everyone. So first I want to say thank you. Like the EAP is actually very comprehensive and I think it's very good. But I have, like one thing which makes me a bit uncomfortable is that one of the introductions for this EAP in order to improve the UX for users, or rather for users of wallets, is that takes origin for type 4 transactions will no longer be guaranteed to be an EOA, right? And right now, okay, firstly, there might be other protocols which depend on it. Well, like normal DeFi ones, but if we even skip this case, then the majority of existing rollups, I mean, like Arbitrum, Optimism, and Eras, like I think, all of them use checks for takes origin for communication between Ethereum and L2. And basically it works like if it's a contract, then its address is aliased, and if it's an EOA, then there is no alias applied to the sender address, to the message sender. And so I'm like curious how is there already a plan to resolve it? Maybe, just from my perspective, it looks like if we do it naively and on Ethereum we implement the same proposal which we have in the RIP, then the assumptions might break and refactoring the code, like changing it in a way which, for instance, does aliasing always for every account, including EOAs. Well, it might be a massive breaking change for the existing integrations with such rollups too.
Yeah, thanks. Yeah, so I also replied this comment pull request. This is indeed it's indeed a problem for how aliasing is done by some of the rollups in the layer 1 bridge contract, but it can be I think it will have to be resolved. It will have to be resolved in some way in these contracts, regardless of this particular RIP, because it also conflicts with a few other EAPs that are being proposed. So then I started thinking about what was the rationale behind this exception. Aliasing is done for everything for every address except for ones where a message sender equals TX origin. And if I understand correctly, the reason for this is because the EOA on the other side is not able to do unaliasing, which normal contracts can do. So in that case, I proposed in my reply to the comment in the PR, I suggested some ways of handling it in this layer 1 contract, and I think that Rollups should probably consider changing this exception, regardless of this particular RIP.
Ari?
Hey, yeah, I've not spent enough time catching up on this stuff, so I will do that after this call. But just to add a little color in terms of kind of the current state of like why aliasing exists and kind of what the point is basically like we early on discovered the issue, which is that just because you control a contract address on one chain doesn't mean you control a contract address on another chain. Um, and so aliasing was introduced in order to avoid issues around that. Yeah, TX origin equals message sender was used in order to sort of exempt EOAs from aliasing. It's a messy system, and like certainly interesting to look at within the constraints of kind of what can be changed without breaking existing code. It's yeah, fundamentally the like hard problem is address namespacing. And that would be the thing to kind of consider in terms of any potential alternatives.
Yeah, so in the context in which aliasing was needed was because of this because the contract on layer 1, you could deploy a contract on layer 1 using the same deployer and create to a different address. And this way you could, since some rollups, including Arbitrum, actually use the message sender from layer 1 directly on layer 2, it made it possible to make calls from a contract on layer 2 that are not actually in the code of this contract. And aliasing solved that. And for that reason, it seems to be not needed for unneeded for EOA. However, this will break as soon as there's a way to add code to an EOA, and there are several EIPs that have been proposed for doing this. Starting with so there's EIP 5003 that adds code. There's the set code EIP 6913. Then there's the transaction type for adding code. That's EIP 7377. So any of these EIPs is going to bring back the same vulnerability, the same potential vulnerability, because you'll be able to have a case where something looks like an EOA on layer 1. It looks like an EOA on layer 1 when you start a transaction, and then it actually does something to an address which is a contract on layer 2. So we are back to the same vulnerability. Therefore, I think that before any of these EIPs is considered on layer 1, we'll also need to change how aliasing. We'll also need to remove this exception in all of these contracts. Otherwise, they all become vulnerable.
Thanks, Yoav. Pooja?
Thank you. Yoav, I have a question for you with respect to the category mentioned here. And before I get into that, thank you for providing the background for the proposal, because I was trying to understand how RIP processes are being evolved. So as per my understanding, RIP is similar to core interface networking ERC proposals, which are standard track type. And core proposals are basically proposals which are proposed for the Ethereum mainnet deploying here. So if we consider this as an RIP, should it be standard track RIP instead of core? What is the motivation behind adding it as a core proposal?
So I don't know. It's RIPs that do change the core protocol currently on layer 2 and later maybe in someday on layer 1. Should they be considered core, or is core only layer 1? I'm actually not I'm not that familiar with the definitions here, but maybe Carl and Ansgar are more familiar with what should be used there. So what do you think?
I think this is one of the issues we need to figure out, and it's something I'm hoping to do sort of as we go. I like the point of the RIP process is to have a place for rollups and extended EVM users to be able to make core changes should they seem relevant to them. And so I'm not particularly concerned with what we call it. If people really feel like we need a new name, we can come up with a new name. But yes, we definitely should be able to make core changes to these things. And that is something that is separate from the IP process.
Of course, that's helpful. Thank you so much. I'm here to just learn about the process of evolution, and we can perhaps discuss this later on some governance call.
Yeah, thanks, Pooja. I think that brings into light many questions we're going to have to work out with this whole RIP process and how it fits in with the IPs, which I think we've seen a few times already. Okay, then moving on, Light Client mentioned he'd like to touch on EIP 3074 and get a bit of a temperature check for things.
I still kind of have a question on the other RIP that nobody really answered in the chat.
Okay.
Just curious, like what the temperature check is for L2's adopting the account abstraction RIP if it's not supported upstream in clients, because as it's written right now, my guess, we haven't talked about this internally with Geth, is we probably wouldn't support it. Like it's just a kind of a large change across the client. And if that's the case, like how do other L2s feel about it? Is there anything, would there be like some spectrum of things that we could do to make it easier to support? Has anyone thought about this?
So first now we have for testing purposes we started implementing our own. So we have a fork with a pull request that implements it. Now I know it's not going to be merged into a Geth in its current form anytime soon, but I think that isn't this the case for any RIP? I mean, every layer two uses some patches on top of Geth in order to implement the modifications. Geth also doesn't have any of the precompiles that are used by different rollups. So I think this would be the case. I mean, the same question should probably apply for any RIP.
I mean, there's two aspects to that's true, but in one sense, they're trying to have the smallest diff between the upstream client and their client. And there's also the idea that having an additional precompile is like kind of a nicely abstracted away thing. You've got this file, and then in some map, you have to put the address in there and link it to the implementation of the precompile. So supporting that is really simple in terms of merging upstream, or sorry, not merging upstream, like doing the updates that are happening upstream and merging them back into your repository, because you're not having conflicts between those implementations. Whereas this is going to be a new transaction type. You're going to, as a maintainer of a downstream project from an L1 client, you're going to run into a lot more of like rebasing issues as you are developing your feature and then trying to get the upstream changes that are happening. It's just very different than a precompile.
Right. So let's hear some layer twos. What's your take, Brent?
Yeah, I mean, I think like Client already kind of said it, but I mean, the two main, I mean, I think probably the two biggest considerations in terms of making changes. One is difficulty of upstreaming and how much it's likely to create merge conflicts, just in that like staying with upstream is important for all sorts of reasons. The other is overall the level, well, there's level of likelihood that sort of it will actually eventually get in is certainly kind of the other and God, I had another point, but it's slipping my mind, so I'll probably come back in with it in a second. We have a variety of deviations already. Oh, sorry, I remembered. The other, and this is like bitten us a little bit before, is I think the biggest risk for rollups that are kind of directly building off of Geth that are making modifications is implicit assumptions in the Geth code base that might change and silently cause issues, which has happened before. And like with this sort of stuff that's like pretty deeply messing with the system, seems risky, since doing those merges is high precision. So yeah, it doable, and it's a very valuable thing to implement. So it's certainly something we'd be quite interested in, but also like pretty scary.
Ansgar?
Yeah, just wanted to briefly say that I think that's another good example of basically, I don't know how right now we are still in a situation where all the tooling and the compilers, the clients, everything still natively targets layer 1, when of course over time layer 2 is where most of the continued iteration and most of the user activity will be. I think especially specifically like a big part of the motivation of this standards process is to basically create some sort of common core of more advanced EVM features. And so those will necessarily over time diverge more and more from layer 1 EVM. The idea is not just, I think, to just basically have EIPs that are going to go to mainnet anyway, just like 5 months earlier for layer 2s. I mean, then I feel like having an entire process for this just wouldn't be worth it. So I think the idea really has to be to have like a more advanced common core that over time will include features like, I don't know, transaction parallelization, state expiry, all these kind of things that make sense for the EVM, but we might not ever want to bring to layer 1 just for simplicity. And so I think we'll have to figure a lot of these questions out in general, like what does it, clearly the right choice here is not to have every single layer 2 team maintain a separate implementation on top of Geth or something of the same feature that everyone supports in the exact same way. So there would have to be some sort of standardization, either with like layer 2 specific client teams emerging over time, or some, I don't know, maybe there could be some sort of common core patch that is collaboratively worked on or something. But I feel like it's not a trivial challenge, but it feels like this is something we have to figure out anyway if this IP process is supposed to be to go to meaningful places.
Yeah, I mean, how do L2s and people feel about figuring that out sooner rather than later? Because I just imagine that we're going to come up with these ideas and you're going to have people going off building projects around different amounts of changes that would happen to L1 clients, but we haven't really figured out how to deal with the situation that the reality is a lot of L1 teams will not support things that are going to be pretty complicated. So the R1 curve, that's something that I think that we could probably support like relatively easily with the configuration flag, just because there's very little overlap with our system and it doesn't really require much like maintenance and we don't have to work around it much. But adding a new transaction type is something that is kind of painful for us to do because we have so many different places where we have to deal with all the different transaction types. And so it's not something that I see that we would be doing if it's not supported on L1. And so we're sort of talking that it needs to be another client sitting between the L1 maintainers and the consumers of these like L2 teams. So it feels like we need to have this discussion sooner than later to figure out how we're going to do it. And if we're not going to do it, then like what can we do if that's the actual reality?
Yeah, I think that like, yeah, two things here that come to mind. One, like, I personally, I'd definitely be in favor of the idea of kind of like a common core sort of fork of Geth that like is actively contributed to across the various whoever's consuming it and kind of implements core RIPs would definitely be happy to contribute there. The other would be, it'll be interesting to think about, and this would be interesting in terms of a question on the Geth side as to sort of willingness of accepting upstream changes that make that add essentially abstraction in the interest of making it easier to maintain that fork. I could imagine a variety of things that we could try to basically like not insert the complexity into Geth, but insert various hooks into Geth kind of for the purpose of being built on by that other implementation. So that's kind of, level of buy-in there. Like I'm completely on board with the idea of like the Geth team can't be responsible for maintaining like everything for every, all the like that makes total sense. But like if essentially it's of enough interest that it would motivate sort of incorporating changes that are low enough on maintenance to sort of make life easier for the kind of core fork.
Right. And I mean, I don't want to speak for the whole team. I'm personally like much farther on that spectrum of being supportive of adding abstractions that make it easier, adding reasonable abstractions that make it easier for L2 teams to interact with this software. And we sort of did this for, we have this 1559 configuration now in our chain config that was proposed by Proto last year, and it took a while for us to, as a team, agree upon that and get it through, even though it was a simple change, just because we had to overcome this exact thing that you're talking about. Like, do we want to add an abstraction that makes our lives slightly harder, but it makes the L2 lives easier? And we did end up accepting it. So I think that the appetite is there. It's just always going to be like a delicate balance of how much complexity does this abstraction add? Because at the end of the day, we're just very focused on shipping a very safe client for L1. And I think like most core teams are pretty focused on that. And it's going to be, it's going to just be a dance with figuring out how to do this in the right way. But having a team that sits in between us and L2s that is focused on maintaining that core client that is implementing RIPs, I think this is a good idea. And I would really like us to spend some time to figure out like how can we make this a reality.
Okay, definitely some interesting things to think about there in terms of how we can manage sort of divergence in sensible ways. Taishan has a good comment in the chat that's worth I think taking a look at too in terms of lessons learned and changes made at Scroll. Ansgar?
Yeah, I just wanted to say that as Matt said, I think for now, while we're still in the process of figuring this out, of course, there are changes that are like small where this might still be feasible to have, say, Geth support, especially if there's at least a good likelihood that they'll also head to layer 1 reasonably soon, so like the R1 precompile. And then there are changes like kind of enshrined 437, which probably like it feels like it would be more important for us to basically have figured out this more fundamental approach here before it would actually be feasible to ship them to layer 2. So I'd just be curious. Obviously, this will take some time to figure this out and set a process for this up. Like maybe a question to the 437 team. What kind of timeline are you kind of right now thinking about roughly? Of course, I mean, time is always a hard question, but for this kind of the enshrining for 437, what do you think is kind of realistic here? And do you think that this basically will be the main blocker in terms of timeline?
So we don't have a timeline for the enshrined version yet. We're still working on it. We recently published this RIP and asking for comments, and we've been collaborating with several layer 2s on some changes that are needed there and some. So it's not close to being finalized, but at the same time. We are working on a Geth patch that implements it, and we are trying to make it as modular as possible so that it can be easily detached and doesn't have too many conflicts. I think that's important. But as for the timeline for doing this, we are very much dependent on layer 2s. We're going to see which of the layer 2s that are looking into it would like to spin up for starters a testnet in order to experiment with it. So the timeline for experimenting with this is less up to us and more up to the layer 2s that are interested in it.
Okay. Thanks, Yoav. Lightline, do you still want to touch on 3074? In the context of L2s?
I can. I don't know if anyone else is on the call who wanted to mention it. Because otherwise I can say.
Okay, just something to keep in mind, since we are discussing both the full account abstraction RIP and the 3074, it's important to keep in mind these are not mutually exclusive, despite some memes going on Twitter. So these are not There are not proposals that try to solve the same thing. No need to go into a full comparison here, but I'm going to post something about it. But keep in mind that these are not mutually exclusive or try to solve the same problem.
Yeah, that's definitely true, and I think a lot of the problem here, I think, stems from the misunderstanding of exactly what account abstraction is. It's become a really diluted term that sort of just means more functional accounts, but really, like, the origin of the term came from this idea of abstracting the way that you authorize things to happen from your account. And it just so happens that a byproduct of that is that it allows us to do neat new things like batching transactions and having social recovery, having spending keys, those types of things. And so 3074 is really not an account abstraction proposal, even though it's like lumped in with that group of ideas, because it looks and feels like the other account abstraction proposals that exist, which have the features just because they're allowing smart contract wallets to do things. So 3074 is really focused on giving EOAs smart contract wallet-like functionality. And there's a long history about how 3074 came about and how it's kind of evolved over the time. And we don't have to get into it on this call, but I have been talking with a handful of different L2 teams and developers, people who are interested in having a renewed interest in 3074, who want to experiment with different ways of creating account abstraction like frameworks and building systems that are really inexpensive for users to onboard to and use, that are, effortless to interact with. And so they have said that it's something they would like to ship on their L2s, but they want buy-in from the RIP process. I don't know if any of those people are here who want to say that their project is pretty supportive. Maybe they could chime in, but I would, just ask, like, how can we move forward with an EIP proposal if that is kind of the case, that it is supported by the RIP folks. Oscar?
Yeah, I just wanted to briefly say that I think more as a general comment that and I think it's important for the IP process to basically that we should not make the distinction too much between supported by the IP process isn't necessarily, I think, a meaningful distinction. I think we should be open to standardizing whatever people, like some subset of rollups are interested in. So, for example, I mean, I'm one of the co-authors as well of 3074. I'm personally somewhat skeptic that now is still a good time to ship it, but I think it's a perfectly fine candidate to turn into an IIP, and then just see, to what extent layer 2s, there could be just some subset still want to ship it or something, or maybe everyone, or maybe no one or something. But I don't think basically we should not turn the RollCall, the IIP process too much into a blessed by layer 2s. I mean, I think it makes sense to have some sort of temperature check, as part of the process, because why not? But I think basically there should not be a blocker of adding an RIP that it needs to get broad support by different people. So I think definitely 3074, it's going to be the same question. It's already an EIP, so how do we convert it into an RIP? So we just need maybe a standardized process for this. But other than that, I think it's a perfectly good RIP candidate.
Yeah, I mean, I think we should hear from the L2 teams how they feel about that specifically, because I don't know if that's how they're feeling, that subsets of people are going to adopt things. But Paul raised his hand.
Hey, yeah, hi. Yeah, sorry, without elaborating too much, I would say that Polygon is very seriously considering 3074, potentially as early as early next year. And I would say that just kind of also it gets into this question about what the way that we approach certain things, and there's definitely at least two different tracks, right? There's areas where we're trying to come to consensus on standardizing implementation across as many rollups as possible, and then possibly with the target of getting to L1 basically, and so the SecP R1 kind of built-ins basically are a good example of that. 3074 may be an area where, it's an opt-in type thing for the rollups, and then the main goal basically is just to maybe, for one thing, not step on each other, and then also if we're going to implement something across several rollups but not all, then to the best we can manage it, basically. I mean, not to the best we should manage it. It should be compliant, basically. It should be a standard, so that that there's consistency across rollups about how things behave as well. So I'd say that's kind of that's an interesting aspect of 3074, which, like I said, some rollups may choose to implement, some may not, but the rollups that do should be consistent, obviously.
Thanks, Paul. Harry?
Hey, yeah, no particular comment on 3074. I just wanted to kind of ask and confirm. So the RIP process is opt-in by in terms of kind of rollups kind of adopting any particular RIP, which makes total sense. I'm assuming, but I wanted to check, I'm assuming RIPs need to be entirely consistent with each other. Like, it needs to be technically possible to adopt all RIPs, that you can't have actual conflicting ones. That would be sort of my only concern here, if there isn't sort of enough buy-in, would be like, is there going to be some other standard that comes along and it doesn't make sense to do both?
And Scar?
Yeah, I don't think this is a really good question, but I personally don't think this is something we can guarantee just conceptually. Like, there's some specific invariants or guarantees that we can make. Like, for example, I think it's good that we would guarantee that there's never a conflict on a specific precompile address, or ideally, even though of course we have a smaller range there on opcodes or transaction types or something. But then in terms of just being able to have like a completely modular field where basically we could guarantee that there's never two RIPs that are mutually exclusive, I don't think, just conceptually, because that's not something that a standards process could enforce, because they can always be, just say, two different flavors of something that's clearly competing, that each supported by a few rollups, and then the IP process should definitely be able to be still a standardizing forum for those competing standards.
Any other teams thinking of supporting 3074? Okay.
Yeah. Not a roll-up team necessarily, but like, I just want to represent that there's significant interest on the application developer side. I think Joe Wong isn't here, but he's super interested in it for Astaria. And then I'm hacking on some new projects right now, and definitely would be interested in it as a primitive for UX improvements as an application developer.
Cool. Yeah, thanks for chiming in. I guess that's pretty much all for 3074. I'm wondering, more generically, how teams feel about RIPs being accepted by a subset of rollups. I mean, it's going to be almost impossible to get every rollup to do everything that everybody wants to do. But part of the point of the process is to standardize and agree upon implementations. And you could imagine this world where we've already been pretty focused on EVM equivalents. So you could imagine we have an L2 EVM standard, and every rollup supports the L2 EVM standard. And we're kind of saying that we're not going to go 100% that direction. We're going to go to a place where some rollups support some of the RIPs. And I just want to confirm that that's also how L2 teams feel about it. Or are you still thinking that everybody needs to kind of be supporting everything because we want to have L2 EVM equivalents?
So I think the important point here is that like one is a subset of the other. If it emerges that people would like to have a L2 EVM standard, and that is something that is worked on, we can maintain L2 EVM or L2 clients around that. I think that's all great. And is definitely an outcome that I think would be really cool to see, whether we can get there, I think, is a different matter, and very much depends on L2 teams' appetite for that.
It certainly seems like having kind of a common core upstream repo that implements stuff definitely like makes it a lot more likely that that things will get widely adopted, which certainly seems like a good goal, like not something the process can like enforce, but certainly something that we can work towards.
Yeah, I mean, just to pick on 3074, because I've talked to some teams about it, and we're on the call partially because they were interested in getting some feedback about how other teams felt about this proposal. Like hypothetically, let's imagine that Polygon and Optimism, want to ship 3074. Like, is that enough of a quorum for you guys to ship 3074? And then the teams who are like kind of lukewarm about shipping, and this is just an arbitrary EAP. You can do this with the R1 curve or whatever else. Are the other teams like, do you feel like that means you need to implement it? Like, because 2 other large rollups have said they want to? How are you guys thinking about that?
I think there'd be a strong argument for it. Because I don't think we have anything against it. I think it's just sort of not like that much on the top of our radar, but like to the degree that it's like a thing that has momentum for it and like could be common tooling that could target it and work on all, that would certainly be really nice. Yeah, I mean, I think it's a lot of it is sort of like, there's a relatively similar issue to like the L1 EIP process of just sort of like mental bandwidth towards like pushing changes, but to the degree that there's kind of momentum, I don't think we're certainly not like against it in any way.
I'm also just asking like maybe more generally, like imagine, Arbitrum and Polygon, you guys have some arbitrary EAP that you're interested in accepting. If you were the only 2 rollups that were supportive of the thing and the other rollups were like, for whatever reason, though, they aren't that interested in it, or it's just not top of mind for them, they can't do it right now, maybe one day in the future, would you still feel comfortable moving forward, even though it's just you and one other rollup doing the thing?
Depends on how breaking it is to the overall experience. Like there are some sorts of changes that are kind of like value add but don't create incompatibilities except for people who are opting into that feature, and I don't think there's any concern about that. Like a simple example of there is like a precompile. Like I don't think we're too worried about that. I think much more worrying would be anything that sort of fundamentally messed with an invariant that like caused you to sort of create subtle incompatibilities that weren't based on kind of clear opt-in from developers.
Maybe something like 1153 would be harder for a small section of rollups to ship.
Yeah, I guess I'd have to say the precise answer is it depends. It really is probably very specific, at least until we probably get more experience in kind of chewing our way through some of these proposals and trying to figure out how to sort them.
Actually, I think another good example might be like another good example is probably like and very apt example is like account abstraction changes that break the the message.sender equals tx.origin assumption, which is like not a good assumption that people should be making, but is a thing that's kind of in normal code. So I think that's actually a prime example of like wouldn't want to break that unless there was a good number of people breaking that.
Well, because it seems to have kind of more
question.
broad. Sorry, go ahead. I'm sorry.
Oh yeah, no problem. You were talking about like not wanting to break invariants. It sounds like you're talking about invariants at the smart contract layer, like code already deployed on chain, not breaking it, but you're not necessarily talking about invariants at the client layer, like.
Yeah, no, I'm thinking primarily invariants that like a developer comes along and deploys a piece of code that they expect to function the same on all chains. And I wouldn't want to have Arbitrum have a deviation that caused their code to execute differently. Which, yeah, I think kind of tx.origin and message.sender assumptions is probably a good example of a place where you wouldn't want to have kind of very different assumptions on one chain than a developer is expecting.
Dano, you've had your hand up for a while.
Yeah, I would say as an EVM developer, the type of fragmentation that scares me more is opcode fragmentation as opposed to precompile fragmentation. Because the precompile space is much larger, it's easier to handle a precompile that's there or not there in your code. But if there's opcodes that have different meanings on different chains, that's going to have toolchain implication. If there's opcodes that are there and that are not there, that's also going to have toolchain implications. Push zero, who here is living this nightmare? That is something that some people support, some people don't, is not something that I think is positive. So I'm wondering if maybe features that may be supported by a subset, that a solution that involves using precompiles instead of opcodes is explored. For example, adding new block metadata could be queried through a precompile. I'd be interested to see if auth and auth call could be implemented through precompiles. And that would be a lot more tolerant to fragmentation across the chains if some support it and some don't.
Thanks, Dano. Ansgar?
Yeah, I just wanted to say that I think this is going to be a very important kind of conversation that we'll have to have anyway going forward. I think because for history kind of context, I think initially the idea for RollCall coming out of last year was to start really with something that looked much more kind of governance-like, to have a proper layer 2 EVM that forks off from layer 1 EVM and really does everything in standardized way and try to get all the layer 2s to opt into that kind of in its whole. But talking to teams, it really seems like there's limited interest in basically giving up sovereignty over the virtual machine to some kind of consortium process. So I think kind of the only way to make progress here is this more opt-in approach. And I still think that any feature that's supported by 2 or 3 chains identically, rather than everyone just doing their own slightly different thing, is still a win, even if it's not opted in by like everyone. And I do think though that there's still a lot of value in trying to then beyond that figure, like find things like some sort of common core. The question would be, would the common core only be all the changes that are supported by literally everyone, or is it more the changes that are like supported by the majority, and so that it's still worth to have that all implemented in one client, but it's still activated by flags or something? But of course, if it's not supported by everyone, then you can't really have tooling targeted, because if you Solidity couldn't just say, hey, you compile to layer 2 common core, because then it's still not guaranteed that everyone supports this. So there might be value in having like a minimal common core instead that's those features literally supported by all the layer 2s. Obviously, I think it's very early. There isn't really a good answer right now, but I do think that this is going to be very, very important moving forward. Otherwise, there's very limited use in a lot of these features if they're not actually properly supported by the toolchain.
Yep, very relevant points. Yeah, thanks, Ansgar. Moving on, just because we're running short on time. Has been discussed on the L1 calls, ACD calls recently. Denkun timelines and testing of all the testnets there. So the 4844 should go live on Goerli early next year, probably February, to my understanding, January, February, followed by Sepolia and Holsky. So if you are an L2, and you haven't been testing your deploying blobs on 4844, I highly recommend targeting these testnets, particularly the Goerli one, as Goerli is going to be the candidate for sort of changing the sizes of what these blobs look like potentially. So yes, please look at testing into these things. And so because this impacts timelines for when mainnet can ship these things.
One
yes,
concern,
Mami?
one concern we have with Goerli is acquiring Goerli ETH. It's quite difficult these days. So is there some kind of way for layer 2 to acquire some for testing?
That is the the big issue with Goerli. I can look into if there is any spare Goerli going around, especially For those who don't know, Goerli will be deprecated after this Denkun fork, so there's no point in hoarding anymore. So I will ask and get back to you. If you do need Goerli ETH for testing, please ping me, and I can see if I can help out there. So I think those are the major topics. One last thing is the call for RIP editors. If you are interested in this, I think it's important to have buy-in from many teams. So please reach out to me if you're interested in becoming an RIP editor. I think it's important that we have lots of representation. And I think that's pretty much a wrap. So thanks everyone for joining this roll call. The next one will be the second week of January. And of course, we'll all chat async before then. And yeah, see you all then. Should be able to find these recordings on YouTube if you've missed anything. But it's been great.
Thanks, everyone.
Thank you.
Thank you.
Thanks,
Thanks,
everyone.
bye.
Thanks.
Cheers.